getting it correct. So we're going to look today at setting out the problem to find the surface area and the volume of an irregular shape, which is what you're asked to do in the assignment. So in addition to this question, I want to find the surface area as well. So find the volume and surface area of this shape. So the first thing I would do here is draw it. I'm not very good at drawing things in 3 dimensions, so I'm just going to draw a side view, which is this plumb bob with a hemisphere at the bottom and a cone on top. If I draw a top view, it'll be a circle with a big top of the cone in the middle. So that's sort of top view, plan view, and side view of this shape. We're told that the diameter of the hemisphere and the cone are each 4 centimeters. So I know that the diameter is 4 centimeters. So that's that distance from here to here, and that distance from there to there, the diameter of the shape, effectively. And I know that the total length is 5 centimeters. So first of all, what's the height of the cone? This diameter here is 4 centimeters. And that's the diameter of the hemisphere. So how can I use that information to tell me what the height of the cone is? That would give me the area, formula for the area. I'm just after this dimension here, the height of the cone, which is this distance from here to here. What will that be? I know that's 5. No, it's easier than that. Look at what we're told. The diameter is 4. So if the total length of that is 5, and I want that, what have I got to do? I could do with knowing what this is. Do I know it? Yeah. Because the diameter of this circle, it's a circle, is 4 rather, so therefore the radius is 2. So this distance from here to here is 2 centimeters. So that means that this must be 3 centimeters in here. So the height of my cone is 3 centimeters. The diameter of my circle on the hemisphere is 4, so the radius is 2. So in other words, I can write stuff down. I can write that the height of the cone using a subscript is 3 centimeters. So the height of the cone is 3 centimeters. And I know that the radius is 2 centimeters. So I've got information from the situation. Okay? I'm after, in the first instance, the volume, and then I'm after the surface area. So let's focus on the volume for now. How am I going to find the volume of that shape? What's my plan? Volume of shape. Or solid, let's call it a solid, that's a better word. What's the plan to find the volume of that solid altogether? Any ideas? I want to find the volume of that thing, so what are you going to do? Times them together? Yeah, add the volume of that to the volume of that. Rob, is that what you mean? Yeah, by adding them together. So if I find the volume of the cone and the volume of the hemisphere, add them together. So the volume of the solid, the total volume equals the volume of the cone plus the volume of the hemisphere. So my plan is to do that, to find the volume of the cone, volume of the hemisphere. Now I go about doing it. What is the volume of the cone? Can anybody remember the formula for the volume of the cone? I'll tell you, 1/3 pi r squared times the height. It's 1/3 of the volume of a cylinder of that height. And you can prove mathematically why that's the case. We're not going to worry about that here. The formula is just 1/3 of the cylinder that the cone is in, if you think about it. So I need the radius, got that, and I need the height of the cone. I've got that. Luckily I've got the height because I worked that out earlier. So I've got them. Yes, I've tried to draw a cone on top of a hemisphere. So you imagine a hemisphere is half a sphere, and you stick a cone on top. Yeah. So to get the total volume, I'd add the two together, wouldn't I? And then I've got the volume. So that's the formula for the volume of a cone. So then I could put the numbers in. Volume equals 1/3 times pi times the radius, which is 2, squared times the height, which was 3. And that would give me the volume of the cone. How do I find the volume of the hemisphere? Yep. How do I find the volume of the hemisphere? The formula, 4/3 pi r cubed, that's the volume of a sphere. So what would I do with that to find the volume of the hemisphere? Half it, right. So it's half that, or divide it by 2. Either way. Or get a half of 4/3 pi r cubed. What do I do? What do I get if I multiply a half by 4/3? What do I do when I multiply fractions together? That's when you add them. When you multiply them, you just multiply top and bottom. 4/6 or 2/3. That cancels down to 2/3. So you could actually call it 2/3 of pi r cubed. And if you think about it, 2/3 of pi r cubed is half of 4/3 of pi r cubed. So, thinking about the fraction, the volume for the hemisphere will be, the hemisphere will equal 2/3 pi r cubed. So I've got the formula. Now I put the numbers in. I've got the radius, so I could find the volume, and I add them together. So the volume would be 2/3 times pi times 2 cubed. And that would give me my volume. And then I would say the total volume equals the volume of the cone plus the volume of the hemisphere, which is, and then I've got the answer. So, recap, and then if you want to write down and finish this, you can do that. I'll give you a chance. Remember that it's the setting out that I'm interested in. A more complex shape than this, you'd even need to be more detailed. But what do? We draw it. We come up with a plan. How are we going to find the volume of this solid? We're going to find the volume of each bit separately and add them together. So then we go about carrying out this plan. We write down what's the volume of the cone, find the formula that will allow me to do that, check I've got what I need, the radius and the height. So if at that point I need to work out the height of the cone, I'll do that. I'll do that little thing we did up here to find the height. And then I can come up with the volume of the cone. What's the volume of the hemisphere? Well, I know the volume of a sphere is 4/3 pi r cubed, this. So the volume of the hemisphere will be half that, which is 2/3 pi r cubed. And then again, I put the numbers in and I get the volume. And finally, V total equals V cone plus V hemisphere. Set it out a bit like this. If you're asked to do this as an engineering report at work, say, That's the sort of thing you would do. You wouldn't just do a quick scribble calculation and there's the answer with a circle around it, because somebody would need to know how you did it. You might need to be reminded what you did a year. You've got this little calculation out of the way somewhere. You need to come back to it at some point. You need to understand what you've done, and so do other people, particularly me, because I'm marking it. Do you see what I'm trying to do here? I'm not saying you've got to do this exactly, but it's got to make sense. And this is as good a way as any. Write down the plan of action and then do it, and then come up with your final answer at the end. Okay? So can you just finish that problem and work out the total volume of the cone? So to set out the problem, the sorts of things to remember to do are draw it. So and put on the measurements, okay? Check units are consistent. Sometimes you might have some measurements in centimetres, some in millimetres, some in metres. They need to be consistent if you could do any calculations. So that's what I mean by that, okay? So when you're putting all the measurements on, you can then check the units are consistent. Write a plan of action. What are you going to do to work out the volume or the surface area, whatever it is you're going to do? Write out a plan of action, guys. So draw it, check the units consistent, write a plan of action. Identify the relevant formulae. What formulae am I going to use? That might involve rearranging it as well. I might have to rearrange a formula to find what I'm after. So maybe rearrange. And then do the calculation. So once you've written your plan, you identify the relevant formula, you do the calculation, in other words, you carry out your plan, and then finally you give your answer with unit and accuracy. So those are the sorts of steps that you would follow. You might not always need to do every step depending on the problem, but those are the sorts of things to consider when you're faced with a problem to solve. So with this plan in mind that we've just written down, let's go back and find the surface area of this particular shape, okay? So we've drawn it. So I've done number 1 for you and put on some values. The diameter is 4, so the radius is 2. So I've drawn the radius here as 2 centimetres. The height, we found out the height of the cone, that was 3. So now we need to find a surface area. So the next step is to come up with a plan. So what's the plan going to be to find the surface area of this thing? Plan. What would you do? Same one, but we're now finding the surface area, not the volume, Rob. Are they? Yeah. What am I going to do to find the surface area of this thing? So find the surface area of the curved surface of the cone. Okay, so having identified the plan, find the curved surface area of the cone, which is pi RL. We know how to find L using Pythagoras. And finding the surface area of the hemisphere, 2 pi r squared. We just do our calculations. So, surface area of the cone equals pi times r times L, pi times the radius, which is 2, times, and if you want to, you can do it in one hit on the calculator. What's L? It's the square root of 2 squared plus 3 squared, because the height is 3 and the radius is 2. So you can do that in one hit on the calculator to end up with the surface area of the cone, which turns out to be, thank you, 22.62 cubic centimetres, square centimetres this time, because we're finding an area. Surface area of the hemisphere would be 2 times pi times the radius squared, so that's 2 times pi times 2 squared, which is 25.57, is that right? So now to get the total surface area, add them together, okay? Equals 25, 45, 47, about 48 point something. 48 point. Have we worked it out? Did he?
Yeah, it's 25.1, not 25.
Oh, is it? Okay. 47.75 square centimetres. So a bit of a dispute about that second one. But, okay, that's what you do. And I forgot to put the